Good day, students. My name is Meshach Ojugo. I'm your physics tutor. I welcome you back to class again. Today we'll be considering the topic vector and scalar. What is a vector? A vector is a quantity which has magnitude and direction. And we have examples of vector. We have velocity, we have acceleration, we have momentum, we have density, etc. Then the next one is scalar. What is a scalar? A scalar is a quantity which has only magnitude but no direction. Remember. Now, what are examples of scalar or a scalar quantity? We have mass, we have distance, we have temperature, so on and so forth. Now, let's talk about how a vector can be represented. A vector can be represented by drawing a straight line. Now, this is just a straight line. Mathematically, this is just a straight line. But in physics, it's not a vector. What makes it a vector is when it has a sense of direction. So if I add this arrowhead, this is a vector quantity because it tells us that this line is going this direction. And we call this point O, and this is A. So we can say that the sense of the vector is from O to A, not A to O. So this is why we have a vector quantity represented a straight line with an arrowhead. But a scalar quantity can just be a given quantity. Like distance, you can add 3 meters plus 2 meters, it gives you 5 meters. Or 2 degrees Celsius plus 5 degrees Celsius, it gives you 7 degrees Celsius. That is just addition of scalar. Now let's go to addition of a vector or vector quantities. Addition of vectors. We have two conditions. Now if I have two vectors acting in the same direction, to determine the resultant simply means that single vector which has the same effect in magnitude and direction as the two vectors acting together in the same path. Now, what do I mean by that? If I have, this is a vector, let's say this is vector A, and I have another vector, this is vector B. You can see that the two vectors are going the same direction. So how do I sum them up? To sum these two vectors, we use the symbol for vectorial representation. So I'll draw another line to join these two lines together, which have another vector C. So to add these two vectors together, we have vector C equals to vector A plus vector B. So we've been able to add these two vectors together on the condition that they act in the same direction. So now let's talk about subtraction of vectors. Now, how do we subtract two vectors? Now, the condition in subtracting two vectors when they act in different direction or in opposite what direction. Now, let's imagine if I have another vector, let's say this is vector B, acting in this direction. Then I have another vector, this is vector A. You can see that this vector is going upward, while this one is coming downward. So the direction is different. So they move in different directions. So to find the difference between these two vectors, we add another single vector which has the same effect in magnitude and direction as these two vectors acting together, which is the resultant vector. So we have C. So C to be given as B minus A. So this is the difference between these two vectors on the ground that they act in opposite direction. Now, what about when two vectors act perpendicular to each other? We have something of this nature. Let's say this is vector 1. We can have here as F1 and F2. So this is one vector acting perpendicular to the other. So how do we determine the resultant? Which is the line that joins these two vectors together. This is called the resultant. So remember in mathematics, we talked about Pythagoras theorem. Pythagoras theorem is used to determine the resultant when two vectors act perpendicular to each other, which is given as r squared f1 squared plus f2 squared. So from here, we can determine the resultant between the two vectors acting perpendicular to each other at the angle 90. Next is resultant and equilibrant. Now, resultant, we said that a resultant vector is a vector which has the same magnitude and direction as two other vectors acting together. That means it has the same effect as the two vectors acting together. Now, what's the decision between the resultant vector and equilibrant? So we have something of this nature. Now, this is an equilibrant vector. Why these two vectors can be joined together by a resultant vector. So this is the resultant vector. So an equilibrant vector is a vector which acts in opposite direction to the resultant vector. So you can see that the equilibrant vector is acting in this direction, while the resultant vector is acting in the opposite direction. So the two vectors has been joined together by the line, which is a single line, which we call the resultant vector. Now let's take on the law. We call the parallelogram law of vectors. Parallelogram law of vectors. What is the parallelogram law of vectors? It states that if two vectors with the same magnitude and direction are acting in adjacent side, the resultant is represented in magnitude and direction by the diagonal of the vector drawn from the common point. I go back again. The parallelogram law of vectors states that if two vectors acting together in which has the same magnitude and direction, the resultant of the vector is represented in magnitude and direction by the diagonal of the vector drawn from the common point. How do we illustrate that? Now we can see we have vector A and another vector B. Now we said the resultant vector joins the two vectors together. This is the other vector. So here we have, this is obtuse angle. Remember, this is obtuse angle. So we have 180 minus theta. And this is acute angle, which is less than 90 degrees. So we have alpha to determine the acute angle. Then the resultant of the two vectors can be represented or can be calculated using cosine rule. That's in mathematics. Cosine rule, which we have arrow square. If we have here as f1 and here as f2, we have f1 square plus f2 plus 2f1 f2, then cos 180 minus theta. So normally theta is usually given before we can determine the resultant of the two vectors acting together. Remember that in mathematics we talked about the quadrant. The quadrant, we have the first quadrant, and we have the second quadrant, and we have the third quadrant, and we have the fourth quadrant. The first quadrant is between 0 and 90 degrees, while the second quadrant is between 90 degrees and 180. The third is between 180 and 270, while the fourth quadrant is between 270 and 360 degrees. Now listen, if the angle given is in the second quadrant, that means our sign here will be affected. Take note, but if the angle given is between 30 or between 30 to, let's say, 30, 60, 90 or thereabout, it falls within the first quadrant. That is why we are seeing the relation using the positive sign here. So next, in our next class, we'll take more examples to illustrate how to determine the parallelogram law of vectors. Thank you and God bless you. Bye.